All right, welcome to Chapter 10, Section 3. This is for distance and midpoints, integrated Math 1 or IM 1. So a couple things to go over on this screen. The first thing you should see is the due date. I don't see that on my teacher preview, but you will see it on your screen. Number of attempts is always unlimited, and so that means you can try tests, quizzes, and homework as many times as you would like because it's always unlimited for those three things. Number of questions just lets us know how many are on this particular assignment. Grading policy is best score, so whichever attempt is the best one is the one you get to keep. Partial credit is enabled, so if you answer 1 of 9 questions correctly, you get to keep the credit for the one question or however many you answered correctly. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. That means once I click start, the way I finish an assignment is down here in the bottom right corner, you will see a submit assignment button. I don't see it on my teacher preview here, but it will be on your student screen. So that is how you finish an assignment, is by clicking that button. It does 2 big things. Number 1, like it said, you can't work on anything else until you finish, until you click that button. Alex will assume if you just close this tab when you want to leave, or you close your computer, then it's going to assume that you want to leave this attempt open, and it's going to lock everything else, so you can't work on anything until you come back to this one. Because it assumes that you want this attempt left open. Remember, you have unlimited attempts. We don't need to leave this attempt open. It also saves your progress. So if you've answered questions, you have the green check mark, it's going to know that and it's going to save it. So definitely click that button because it's so we don't get locked out of all of our other assignments. The other big one that it does is it updates the gradebook when you click submit assignment. So your teacher can actually see what you've been working on. Until you click on that button, your account's kind of frozen. We can't even see what you've been working on. So 2 big reasons, always click that button. All right, on the side we have explanation, example, and message center. So explanation tells us we're going to lose our question attempt because it's going to give us the answer to this question. So it's not going to give you the answer and then let you, type it in there. But you can click on example and get an example very similar to what it is we're looking at. So we're going to look at the distance between 2 points that are either directly left and right of each other, so horizontal, or they're going to be vertical like our example. So it's kind of a very simple idea of distance. You can click on this for another example if you'd like, and you can also message your teacher directly from here. It says I can't do that because I'm in the teacher preview, so it doesn't let me do that while I'm in the teacher preview, but it will let students do it. And it attaches a picture so we know where to come help you. All right, let's go ahead and take a look at this. So very simple idea of distance. When I have 2 points that are either directly above and below each other, so they're vertical, or horizontal like the example showed us, so directly left or right of each other, no diagonals here. We get a little bit more complicated when we start going to diagonals. There is a formula for that. But when we just have them right above or below or right and left of each other, all we have to do is count the distance. And go 1, 2, 3, 4, 5. So the distance here is 5. And that's it. Just counting, just kind of getting that idea of what are we doing for the distance. All right, so when we want to find the distance between 2 points, and one thing that we should notice is if I kind of stack these guys, do we notice how these are the same? Well, the x's are the same. What that means is that if I had a coordinate grid here, and I went over to -6, so we're going to pretend like this is -6, I'd go down to -5 and put a point. And then I'm still at -6 and I go up to 3. So they're directly above and below each other. So if we have a matching coordinate, it means they're either right above each other, like this one, if it's the x's. If the y's were the same, then they would be left and right of each other, because I would stay on the same y coordinate for both, if both y's were the same, if we had an example like that one. So when we have it like this, really I just want to know what's the distance between -5 and 3. So make sure you're paying attention. There's 5 here, and then there's 3 here. So even though it's a -5, it's still a distance of 5 from kind of the 0 line here, this axis. So it's a total of 8. So don't do -5 or 5 minus 3 and go, oh well, it's 2. No, it's 5 negative, so 5 below and 3 above. So it's a total of 8 for the distance. And sometimes just drawing a little graph like that can definitely help us visualize, okay, well, what's the actual distance. All right, so this is the basic idea of a midpoint. When we have this, and there's 2 different methods on how they do this one. I'm just going to show you the one that, you know, I think is the easiest one to do with this one. And then we're going to practice midpoint with coordinates when we actually have some coordinates to do this with. Because if you click on example, they show you both methods. And one of them has to do with kind of using coordinates, the midpoint formula. I think it's a little easier to introduce that one in a couple of sections, or not sections, a couple problems here, when we actually have points to do that with. Yeah, on number 6, we're going to actually mess with the midpoint formula. It looks like, oh, nope, that's distance. It's number 7 that we're going to look at the midpoint formula. All right. So when we have numbers like this, the easiest way to do it, you could count back. You know, I could go 1, 1, 2, 2, and it's easier to do that with both fingers. I can't really show you that with the mouse. But I can also just count from Y to W, or W to Y. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 spaces here, which makes sense. There's 1 to the left for the -1, and there's 9 more to the right. So there's 10 spaces here. So it's a distance of 10. I don't want the distance. I want the midpoint. So if I know the distance is 10, oops, and I wrote the answer that I was going to talk about. So the distance is 10. Well, I want to divide that in half because midpoint is halfway. So it's going to be 5. So I'm going to go 5 units, 1, 2, 3, 4, 5, or, darn it, 1, 2, 3, 4, 5, or I could go the other way, 1, 2, 3, 4, 5. Either way, I should land on the same coordinate here, the same point. So the location of the midpoint would be at 4. And it's 5 units in from either side. All right. So let's go to the next guy. All right, so in the figure below, we have, and I'm going to draw this figure because I like drawing the figures. So much easier to look at if I have something to draw on. M-N-O-P. All right, so I have in the figure below, O is the midpoint of MP. O is the midpoint of MP. Did I draw that real nice? Let's see. O is between MP. Sorry, between, not the midpoint. I read that wrong. I was going to say, that does not look like the midpoint no matter how I look at that. I just read it wrong. O is between MP. And sometimes when we're doing this, and I know they used to do this out of the textbook more, they would give you this description, but not show you the line. You had to draw it yourself. So by telling me that M is, or O is between MP, it just gives me an idea of, I would draw the line MP, or this line segment, and then I put O somewhere in between them. N is the midpoint of MO. So N here is the midpoint. Well, if it's the midpoint, remember that means halfway. So that means that this point, this section and this section are going to be the same. They're going to be equal to each other because this is the midpoint. It's right in the middle, in half. All right, and then they tell us that MP, and I'm going to switch my color up here, MP, which is the whole thing, is 16, and NO is 6. If NO is 6, MN is 6, because remember, halfway. So these guys are equal to each other. And then it says find OP. All right, well, we've already filled some pieces in here, right? So I want to find this section here on the end. This is segment addition, and we dealt with this in the last section just a little bit. If you haven't watched the section 2 video, that was the very last problem we did, it was the introduction to segment addition. So the idea here is if I have a whole segment, which would be the MP, I can take the little pieces and add them together to get the whole segment. So I can take a look and say, okay, well, if I'm using 6 and 6, which is a total of 12, right? If I'm looking at this whole segment here, it's 12 together, is 6 and 6. And the whole thing is 16 from M to P. What's left over for my little piece here? 16 minus 12, well, that would give me 4, right? So there's only 4 left over for that one. I could also write it a little bit more algebraically and go 6 plus x has to equal 16 because these are all the segments for the whole thing, and the whole thing is 16. So then I have 12 plus x equals 16 because I'd add my like terms together and I'd subtract 12 from both sides. Do you notice how this looks a whole lot like what we just did, kind of out loud? 12. And I have 12 minus 12 cancels out. Anything minus itself cancels out. X equals 16 minus 12 is 4. So this is exactly what we did out loud, where I said, well, I'm using 12. There are 16 total. What's left over, 16 minus 12 is 4. So I did that same thing kind of visually out loud. So I'm looking at the visual and I'm thinking about it. Or I can do it algebraically. And so I'm going to add all the segments together, and that's going to equal the total segment. So kind of either way that you want to do it there. All right, so this guy, now we're getting into distance on a diagonal. So we can't simply count between them. That's not how this works. You can only count if it's directly above or below, or directly, right or left. But if we're on a diagonal, we have to use the distance formula. So the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we just jumped into this, very long, kind of complicated looking formula. This actually comes from, if you remember, Pythagorean Theorem. And if we have these 2 points here on the line, or on the coordinate grid, I can connect them to make a line, right? So that's, hopefully we all understand that. We can connect 2 points. Darn it, I cannot draw a straight line right now. Better. So I can connect them to make a straight line. I can also go straight down here and straight across here to do rise and run. So this would be my rise, this would be my run, and I can do Pythagorean Theorem here, because this would be A, B, and then C would be across from this 90 I just created. So that's A squared plus B squared equals C squared. Well, the distance is C. So if I kind of wanted to make this look a little bit more like this guy, I would take the square root of both sides like this, and I would have the square root of A squared plus B squared equals just C, because the square root of C squared is just C. I can't do that with these guys because they're being added together, so they have to stay under here. So if we notice, C kind of relates to D, and then I have A squared, which could be the x's subtracted from each other, and B squared, which could be the y's subtracted from each other, because see, I still have these squares. So even though, yes, it's a little bit more complicated looking when we get to this point, when we're doing this, it's the same idea. It's Pythagorean Theorem. We're using the idea of a right triangle. We're just writing it with coordinates. So what does x2, x1, y2, y1 mean? Well, we have 2 points like this. And they're going to tell us the 2 points. They give us the coordinates for the 2 points. Like we can see them here on the grid. So we're going to have x1 and y1. And there's a comma. And then we have x2 and y2. And what the 1 and the 2 mean is it's coming from point 1. So this is my x coordinate from point 1. This is my y coordinate from point 1. This is point 2. So this is my x coordinate from point 2, y coordinate from point 2. It's part of the name. That's all the 1s and the 2s represent there. If they're dropped down low. If they're lifted up high, that's an exponent. That's actually a math operation we need to do. But if they're dropped down low, it's part of the name. So, just be aware of that. We definitely use this a lot when we're naming things. Especially when we have multiple points, because we need to know where are we grabbing the point from. So I'm going to erase point 1 and point 2 just so I can go away. I'm going to write these underneath. So I'm going to have 1 and negative 3 and 8 and negative 8. So if you add labels above your points or below your points, however you add the labels, makes it super easy to go through and fill this in. So I'm going to have distance equals, and I'll put the square root sign before I change my colors. We're going to have these 2 pieces plus these 2 pieces. And the minus signs are part of the equation. So make sure don't change that part. Even if they're negatives here, we want to see the double negative. And I'll explain that when we get there here in just a second. So I want to go x2, which is 8, minus x1, which is 1. And then y2, that's negative 8. And then y1, which is negative 3. So I'm literally just plugging in these pieces. But I didn't change all the essential parts of the equation here. And if you see this is minus negative. I want to see that. This negative is part of the equation. But now I have another negative in there. So now I'm going to reduce this. So I'm going to start simplifying. 8 minus 1 is 7. And negative 8 minus negative 3. Minus negative means it's a plus. So I'm going to have negative 8 plus 3. I have to subtract those, and there's more negative than positive now, so it's negative 5 squared. All right, so 2 more steps here, I think. We have 7 squared, that's 49, because remember, it's not 7 times 2, it's 7 times 7. Plus, we have negative 5 squared, again, it's negative 5 times negative 5, so 25. And so now I need to combine these together. Let's see, I get 14, because 9 plus 5 is 14, and then 4, 5, 6, 7. So I get 74 there. 74 does not, it's not a square root, or it's not a square. So I know it doesn't have an even square root. But let's see, if I divide by 2, what do I get? I get 37 and 2, so that's not going to work. So I believe we're just going to leave it the square root of 37. So if I could break it down, if there was some other square in there, I would kind of break it down a little bit more, but it doesn't look like I can break that down anymore because the only 2 numbers would be 2 and 37, and neither one of those has a square root. So I'm just going to leave it alone, and it's going to be the square root of 74. It says give exact answers, not a decimal approximation, so it doesn't want us to take the square root of 74 and type it in here. It wants us to leave the square root sign. All right. So I believe we're going to do distance formula a couple of times now, so we're going to practice this guy a few times. All right, let me go back, and I'm going to rewrite my distance formula. Oh, you know what? Can get rid of that too. So I have, so with this one it says here are the endpoints of the segments PQ, RS, and TV. So here they are, here are our endpoints, and then follow the directions below. Find the length of each segment, and then they want exact answers, no approximations, so they still want the square root signs if we need them. And then check all statements that are true. So we're checking to see, are any of these segments congruent to each other? That's what we're going to check to see. Well, I need to know the distance of all 3. I'm going to have to do the distance formula 3 times. So I'm going to write these out. So let's see, P negative 4, 5, Q, that's negative 7, 7. So this is x1, y1, x2, y2. Again, adding those little pieces definitely helps. Just throwing those little labels on there, because now I don't have to worry about which one is which. I can just grab them. So we have these guys plus, minus, minus these guys. Okay, so let's go ahead and fill this guy in. So I have x2, sorry, almost circled the wrong one, x2, and x1, and y2, and y1. All right. Let's go ahead and start filling this guy out. So we have square root, so I have negative 4 plus negative 4, sorry, minus negative 4, which turns into a plus. So I'm going to subtract, and 7 is more negative. There's more negatives than positives. That's why it's a negative 3. Plus, we have 2, because 7 minus 5 is 2. So this is going to be the square root of 9. Negative 3 squared is 9. Plus 4. 9 plus 4 is 13. Square root sign. So I'm kind of doing this a little smaller so I can hopefully fit all of these on one screen. We will see as we move forward here. Alright, so my next one is going to be R and S. Okay, so I have x1, y1, x2, y2, and I have D equals the square root of the x's subtracted and the y's subtracted, the difference of the x's and the difference of the y's. That's the way we say that. All right, so x2, and that was supposed to be a negative 1. That came out really horrible. Negative 1, and x1 is 1. y2, negative 3, and y1 is negative 6. All right, so I'm going to go through and start to simplify this guy. So I have negative 1 minus 1. Well, that's negative 2. They're both negative. I had negative 1. I went one more negative. So that's negative 2. And plus negative 3 minus negative 6. Remember, that's going to be a plus, two negatives make a positive there. The two negatives kind of negate each other. So I end up with 3 squared. So now I have negative 2 squared is 4, because negative 2 times negative 2. 3 squared is 9. So look at that, I'm ending up with the exact same thing. So I have the same thing again, and I'm going to be lazy and go copy, paste. If you don't know the shorthand controls like that, they are very, very useful. So, don't have to have them, of course, but just, fun, useful things if you know how to do copy and paste. Alright, so I have x1, y1, x2, y2. And I'm going to switch to blue. Alright, so x2 is 5, x1 is 3, y2 is 3, and y1 is 0. So now I have d equals the square root of 5 minus 3 is 2, plus 3 minus 0 is 3. Looks like I'm going to end up with the exact same thing again. 2 squared is 4, 3 squared is 9, and I wrote that way too big, but so they all ended up being the exact same thing. Interesting. So they're all equal. So with this one, we tested all of them. They're all equal to the same thing, so I can say they're all equal to each other. So usually I found these ones where none of them were equal to each other. So it does happen where you have them all equal to the same, or they can all be equal to something different. So it kind of just depends on the coordinates that Alex throws at you there. All right, this is the one where we're going to do the midpoint. So I'm going to get rid of this stuff. Midpoint is similar in some of the calculations because we're still using the two coordinates. So the midpoint formula, what we do is we write it as a coordinate like this, comma in between. And what we're going to do is for the x coordinate, we're going to have x1 plus x2. So the x coordinate of point 1 plus the x coordinate of point 2, and we're going to divide that by 2. Because remember, midpoint is halfway. Oh my goodness. And then we're going to go y1, it's doing x again, y1 plus y2, and again, divide by 2. So we're adding the terms this time instead of subtracting them, and then we're going to divide by 2. So this is the midpoint formula, and again, we're going to be given 2 points. So in this case, we're given P. I don't know where I'm writing equals, but they wrote equals up there. I think that's why I did that. Sometimes they put the equal sign and sometimes they don't. It's kind of interesting. So this is x1, y1. This is x2, y2. Now, I keep doing this in this order where I'm doing point 1, then point 2. Does that really matter? Could I do it the other way? Could I say that this is point 2 and this is point 1? Yes, I can. The main thing is once I decide which one is point 1 and which one is point 2, I have to keep that consistent for the entire problem. So I can't say, to find my x's, that this is point 2 and this is point 1, and then when I go to my y's, I flip it and go point 1 and point 2. That's going to change some of my signs and change things a little bit. Because we're adding, it's not going to make as big a deal on this one. When we're subtracting with the distance formula, that makes a very big deal because that might change that double negative problem where it changes it to a positive. So just be careful about that. But you can choose this is point 2 and this is point 1. That's perfectly fine if that's what you wanted to do. And if I was looking at this, that actually might be how I do it on the graph. I tend to go from left to right for whatever reason when I'm looking at this. So I'd say Q is point 1 and P is point 2. But again, doesn't matter which one is which as long as you choose and you keep it that way. All right, so let's go ahead and change this up a little bit. So we're going to have our coordinates here. It's going to be plus, and then we're dividing by 2 no matter what. So these pieces aren't going to change. What is going to change is what we plug in here. So x1, I changed my mind on that one. This one's x1, -5, and this one's x2, so -1. And then y1 is 8, and y2 is -6. So now we just want to reduce. So I have -5 minus 1. Well, that's -6. I had 5 negative, I want one more negative. And then over here I have 8 plus negative 6. So it's really 8 minus 6. So I have 2, sorry, not 4. 2 over 2. All right, I'm going to reduce one more time because these are both even, so I can reduce these. Negative 6 divided by 2 is negative 3, and 2 divided by 2 is 1. So my midpoint is going to be this coordinate, negative 3, 1. Negative 3, 1. And they tend to label the midpoint M, just because it kind of makes it very easy to think about there. All right. Last two here, we are going to go back to Pythagorean Theorem, and I started talking about this with the distance formula. So we're going to reintroduce Pythagorean Theorem here so we actually get to practice it a little bit. So Pythagorean Theorem says if I have a right triangle, which I can see it's a right triangle because it's a little square. So right triangle means it has a 90-degree angle. I can use Pythagorean Theorem, which is a squared plus b squared equals c squared. A and b are the legs. Just trying to do. Go back. Where'd my 2 go? There's my 2. Should rewrite it. I don't know why it disappeared. So these are the legs. And what that means is they're the sides that create the 90 degrees. This is the hypotenuse. Hypotenuse. I hope I spelled that correctly. And it is across from the 90. So we go across. It's not the one creating the 90-degree angle. It's the other one that kind of diagonal that's connected between the other two legs. So as long as we make sure that C is the one that's across from the 90, A and B don't really matter. This could be A, this could be B. Or this could be B and this could be A. A and B can kind of be flip-flopped as long as they're the legs. Okay? So I'll just go ahead and go AB like that. Why not? So we have 40 squared, because A squared plus B squared, so 9 squared equals C squared, which is X, because that's the value they gave us for C, or for the length C. So now I'm going to go through, and they did give me a calculator on this one. So 40, and we have the little squared button, so we can always click on that. So we have 1600 plus 9 squared, that's 81. I already know that guy. 9 squared is 81 equals X squared. And so if I go plus 1600, that was too many zeros, equals 1681. So now when I'm at this point, what I want to do to find just x, because I don't want to know what x squared equals, I want to know what x is, I'm going to take the square root. Remember what that means is if I have 2, a square is the same number multiplied by itself to get that answer, to get that product. A square root is I'm asking what number did I multiply by itself to get this number. Well, x squared is x times x. So what number did I multiply by itself? I multiplied x. So I can take out 1x because that's the square root. That's the number I multiplied by itself. And then to do this for this number, what I want to do is hit this little button here, this square root button, and it'll go over the top. You want to make sure different calculators react differently to that. I know when I'm doing this on my smartphone, I have to type the number in first and then hit square root. When you're doing this on here, you're supposed to hit the square root button first and then type the number in. I had it highlighted, which is why it put it underneath there for me. So this guy is 41. I had a feeling it wasn't going to be any kind of decimal because they haven't given me any directions for rounding or using exact answers. So I had a feeling it wasn't going to be a problem. All right, so we have this guy. All right, one more of these, and it's just going to be another Pythagorean Theorem problem. So we had 2 of these guys. All right, so now even though it's turned kind of sideways, here's the 90 degrees, so my legs are 12 and x. So this is my A and my B, and the 17, that's going to be my C. This says round your answer to the nearest hundredth, so I'm not going to end up with a very nice number. So I'm going to go A squared plus B squared equals C squared. So I have 144 plus, because 12 squared is 144, and I'll do that over here on the calculator. So I have 12 squared, like that. X squared is going to stay x squared for a minute. 17 squared, I think that's 289. Oops, not a 117. 289? Yay, 289. 289. So now I need to get x squared by itself. I'm going to subtract 144 from both sides here. boom, 144 minus 144 cancels. X squared equals, so I have 289 minus 144, and I get 145. Well, 144 is a square, so I know that 145 is not a square. So that's, I already know I'm going to end up with a decimal because the directions told me I'm going to be rounding to the nearest hundredth. So very good clue that I'm going to have some kind of decimal answer there. So same thing, I'm going to take the square root. X squared, what did I multiply to get x squared? I multiplied x and x, so I multiplied x by itself. So the square root is x. And then I'm going to go over here. It's already highlighted, so I can just click this button, and it'll insert it for me. If it wasn't highlighted, it wouldn't insert correctly. So just be careful about that. Or if I want to round to the nearest hundredth, so this is a whole number, this is a tenth, this is a hundredth. So this is where I want to round to, but I need to look at this next number and make sure that it's not 5 or bigger. Since it's 1, that's 4 or smaller, they just drop off. The 4 doesn't change. If it was 5 or bigger, you'd round up. So, and I believe it will, in fact, let me copy and paste. All right, so we have 12.04, or 12 and 4 hundredths is another way you could say that. All right, so that was section 3. I will see you in section 4.